All right, we are starting in on Unit 4. This will be the last unit before you take your midterm or interim exam. So we're going to start qualitatively, so non-numerically, talking about the conservation of energy. So a few things we've got to kind of get you understanding is the difference between system and surroundings, what happens when heat is absorbed or released, and a couple of key terms, exothermic and endothermic. So first thing is just to get down what the difference is between the system and your surroundings. All right, so when we're talking about these thermodynamic, heat processes, there's your system, which is the actual chemicals going through the process. All right, so that might be the actual, water molecules that are boiling, or the water and sugar dissolving, or the chemicals that have bonds breaking and forming. All right, if they go through a reaction, the chemicals, there's going to be some bonds that break and then some bonds that form, and then the overall process is either going to lose heat or gain heat. Then there's the molecules that are surrounding those that are going through this process. That's going to be your environment, your surroundings. All right, so if you've got water and sugar dissolving, there's going to be some water molecules on the outside, the glass, the air, everything outside of that process is part of your surroundings. Or if you have, in a glass, in a container, a reaction happening, so maybe you have a combustion reaction happening. So you have oxygen reacting with a carbohydrate type compound, all right? The air, the container that contains the reaction, all of that stuff on the outside, not actually reacting, is your surroundings. All right, so the system is what's actually doing the process, and then the surroundings is everything else that's nearby that may experience a change because of being near a process or reaction. All right, and with this, there are two processes can be categorized in one of two ways. There can be an exothermic process, meaning that your system, the molecules that are undergoing some sort of reaction or change, give off energy. All right. So in that sense, the temperature of the system, if they are giving energy away, the temperature of the system is going to go down. All right, and then because the system is giving off energy, all right, the surroundings are going to gain that energy, and their temperature is going to go up. All right, so a very, very common exothermic reaction that you are probably familiar with is anytime something burns. All right, the chemicals themselves are actually losing energy and giving that off to the environment so that you can feel that heat, because you're not going through the reaction, you're in the environment, the surroundings. All right. Endothermic, on the other hand, is the exact opposite. The system absorbs or takes in the heat and energy. So the temperature of the system in this case is going to go up, and then if you're on the outside of this, your temperature in the surroundings is going to go down. All right, so some ways that I try to remember this. Exo to me sounds like exit. All right, so heat exits the system. And then to me, endo kind of sounds like in, or the heat goes into the system. All right, there's also, you've got therm in there in both of these, and that's how you can remember that's heat. And the trick is just these words are defined based on what's going on in the system, the actual molecules going through the process. All right, so sometimes it's easier to think about what you would experience, but you got to remember that generally speaking, you're going to be outside of the system. All right, so what you experience is going to be the opposite of what the molecules in the system is experiencing. All right, so you experience the opposite of the definitions. Okay, So let's think about a few of these as being either exothermic or endothermic. And I chose these examples kind of on purpose, particularly the two dissolving ones, because I know you're going to see questions related to them. But they're not going to give you all the details that I give you in the parentheses when you run into these question-wise. All right, so this is just kind of getting you thinking about this stuff. So, a cooling ice pack. This one you can probably figure out on your own, as long as you remember that you would be on the outside, the surroundings, and the ice pack is their system. All right, so the ice pack is going to be making the surroundings cooler, all right, because you on the outside, you use the ice pack to cool yourself down. All right, so in the environment, the surroundings, the temperature goes down, which means that the molecules in the ice pack, their temperature actually has to be going up. They're absorbing energy. All right, so the system absorbs. Which makes this endothermic. All right, so that's one of those things where, the easiest way to think about this is what you feel, because using an ice pack, it's going to feel cold on you. But then you have to remember, if it's what I'm feeling, okay, the opposite is actually happening inside the system. So, dissolving hydrochloric acid in water. All right, you're going to see this as a choice in some of your questions, but I want you to know that the hydrochloric acid, all right, and then the water molecules that are actually, working in this dissolving process, their temperature is going to go down. All right, and then the surrounding water molecules not involved, the glass, the air near where this is happening, their temperature is all going to go up. All right, so if the hydrochloric acid, which is actually your system, is losing temperature, losing energy, all right, that means it's giving the energy away. That means that we've got an exothermic reaction taking place. All right, whereas sugar dissolving in water actually makes the sugar get hotter, and then the glass and the surrounding things not involved in the dissolving, they are going to get cooler. So again, the sugar is absorbing energy, so that's endothermic. All right, so dissolving isn't always one or the other, which is why I don't like that you have some multiple choice questions that just give you like, which one of these is going to be exothermic, and then you have to kind of know what's going on, which is why I'm telling you about these two. So I recommend writing these two examples down, all right, because I know you're going to see them in choices, all right, and they have opposite answers. All right, so unfortunately, there's not much more you can do other than write these down and then remember to look them up. Okay, so these three I think are more ones that you can actually don't need to be given extra information for, and if you just kind of think about what's going on, you'll be able to figure out if it's exo or endothermic. All right, so just remember, exothermic, system gives energy to surroundings. Endothermic, the system takes energy from surroundings. All right, so you can think of it as the direction that the energy goes. So, in an explosion, all right, you've got your system, and you're going to feel heat and fire and all of that sort of stuff. All right, so that's energy being given off. That's going to be an exothermic example. All right, ice melting. All right, your system is going to be your ice. So we're going from a cube to, liquid. All right, so think about what's going on here. Our molecules are going to be absorbing energy, taking heat away from the system so that the water molecules themselves can move around more. All right, so that's going to be endothermic. All right, our water molecules have to get warmer, which means they have to absorb energy. All right, and how about if we go one step further and we take that liquid and we turn it into gas molecules? All right, that's the same direction, just going one step further, so we're absorbing even more energy. That's also endothermic. All right, where's the reverses of these? All right, so freezing ice, all right, or condensing water. Those are all going to be exothermic.